Good morning, statistics class. How are we doing? Looking at one of our last topics for this school year is combinations and permutations. Okay, we're rolling in our probability unit. These are something that you deal a lot with, but you actually don't think about. And there is a slight difference between the two. So it does start out, what is the difference? A couple of examples, the fruit salad combination of apples, grapes, and bananas. If you combine those, we don't really care which one goes first. We don't care if you put the grapes on first or the bananas on first. It does not matter. As for the example of the safe, that does matter. So that is one of the big differences. It says when the order doesn't matter, it is a combination. When the order does matter, it is a permutation. Okay, in other words, a permutation is an ordered combination. To help you remember, think permutation, position. Position does matter. Excuse me. When the order does matter, permutation, position. Okay. These notes are on Google Classroom. They were uploaded for you this morning. So just kind of flipping through this. Two types of permutations. One where repetition is allowed, such as the lock above. It could be 3, 3, 3. Repetition is allowed, or no repetition. For example, the first three people in a running race. You can't be first and second. You can't have somebody be in two spots at once. So, permutations with repetition. Okay, easy to calculate when a thing has n different types. So n is a number. Okay, number of different types. We have n choices each time. For example, 3 choosing things. So, let's say you have apples, bananas, and grapes. You have 3 choices for each. 3 times 3 times 3. In this case, allows you to figure it out. Okay, or if you just keep scrolling on down here, you'll see it gives you the equation. Okay, n is your number of options. How many times are you choosing? That gives you how many total choices there are. Okay, how many total options. Okay, so those ones are very, very straightforward. It says, example in the block above, there are 10 numbers to choose from, 0 through 9. And we choose 3 of them. So 10 the first time, 10 the second time, 10 the third time. There are 1,000 different permutations, 1,000 different ways to order 0 through 9 with repetition. Okay, so the formula is simply n to the r power, where n is the number of things to choose from, and we choose r of them. Repetition allowed, and order matters. Okay, order does matter in that scenario there. Now, the more difficult ones. Permutations without repetition. In this case, we have to reduce the number of available choices each time. Example, what order could 16 pool balls be in? Well, so our first choice has 16 possibilities, next choice has 15, 14, so on and so forth. Okay, they do the calculation for you, 16, 15, 14, 13, 12, 11, 10, so on, all the way down. Okay, now, this problem right here, there's no need to go 16 times 15 times 14 times 13 times 12 on your calculators. Okay, there is a cool, it's called factorial. It's down here, they bring it up. I'm going to bring it up a little early, but the factorial function is an exclamation point. Just means to multiply a series of descending natural numbers. 4 factorial, 4, 3, 2, 1, so on and so forth. That is, if you're looking at a TI 83 or 84, if you go math, over to PRB, stands for probability, you'll see it's the 4th option. It's the exclamation point. 2 and 3, NPR and NCR are also important. Okay, so keep that in mind. It's math probability to go over there and find it. So maybe we don't want to choose them all, just 3 of them. Well, then we'd be choosing, we have 16 options, 15 options, 14 options, so on and so forth. In other words, there are 3,360 different ways that 3 pool balls could be arranged out of 16. Without repetition, our choices get reduced each time. Okay, so on and so forth. So, not too complicated. Okay, it's just remember your options have to be getting reduced each time. When we want to select just 3, we don't want to multiply after 14. How do we do that? There is a neat trick. We divide by 13 exclamation points. So they're trying to give you an equation here, in a sense. Okay, it says that was neat. The 13 times 12 times 11 gets canceled out, leaving only 16 times 15 times 14. Yes, we could do 16 times 15 times 14 on our calculator quite simply. But let's say you're doing numbers in the hundreds, okay, or thousands. You don't want to have to do that, all those calculations out simply. Let's say you're choosing 200 or 200 choose 50. That's going to be huge calculations there. So that's where this equation comes from. N factorial divided by n minus r factorial, and where n is the number of things we choose from. We choose for r of them. No repetitions in order matters. We're doing permutations. They give you an example down here, so on and so forth. Okay, so just some examples. This is permutations. Okay, this is all permutations notes. I'm going to do combination notes separate at a separate video here so we can keep them separated. So let me know which questions you have. Thank you.